8.2 to 8.3, part 2. So we're still graphing rational functions, but we're going to be doing it from a different form. So sometimes you'll see a ratio of linear functions, and the shape is still going to be a hyperbola. The vertical asymptote is going to happen when the denominator is 0. The horizontal asymptote is going to be when is at y equals a over c, which is the ratio of the two coefficients of x. And then we have domain and range and then behavior that also go along with the asymptotes. And then the x or y intercepts, those are going to happen when y is 0 and when x is 0 respectively. So let's go ahead and do some examples. So we're going to start out by identifying a and c. So a is in front of the x on top, that's 3. C is in front of the x on the bottom, that would be 1 in this case. And then we can go ahead and find our horizontal asymptote, which is going to be y equals a over c. So in this case, 3 over 1 or just 3? We also know there's going to be a vertical asymptote whenever the denominator is 0. So let's go ahead and set that denominator equal to 0. 0 equals x plus 2. And then if we solve, subtract 2 from both sides, we get negative 2 equals x. So x equals negative 2. Now we can put those on our graph. And y equals 3 is our horizontal one. And then we're going to think about domain and range. So domain, all the possible x values. Well, we know x can be anything except negative 2. So x cannot equal 2, negative 2. Range, y cannot equal 3. And behavior, similar to before, as x goes to positive infinity, f of x, the function, will approach that horizontal asymptote of 3. So it'll never reach 3, but it will approach it. Same thing going toward negative infinity, it's going to approach 3. Now we can go to our calculator and get some values to put on our graph. So again, put this into y equals, and then we're going to press second table. And then you're going to see those values that you can copy down. So here's an example of that. I've got y equals, this button by stat plot, press that, and then we're going to enter our function. See, I've got parentheses in my numerator and my denominator. Let's go to second table, which is right under graph, or right above graph. And then you're going to see the values that you want to put on your graph. I would start right where it says error, because that's your asymptote, and make that the middle of your table. You can put error or undefined here. And then you're going to copy down the rest of the values. So we've got negative 3, 15, negative 4, 9, negative 5, 7, and then let's do 3 on the other side. We've got negative 1, negative 9, 0, negative 3, and 1, negative 1. Graph these points. Looks like negative 315 is way up here, so that's enough. We're going to go ahead and connect these. And then we have negative 1, negative 9 on the other side of our asymptotes. 0, negative 3, and 1, negative 1. Connect those points. And we're done. Last thing is finding x-intercepts and y-intercepts. So we know the x-intercept will happen on the x-axis when the y value is equal to 0. So when is y equal to 0? Well, let's think about this. When could we make y equal to 0? Well, we'd have to have the numerator be 0 for the whole thing to be 0. So, for example, if we want this whole thing to be 0, the only thing we need to be 0 is the top. So you're going to set 3x minus 6 equal to 0 and solve for x. So if we solve, we add 6 and divide by 3, and we get x equals 2. So that means that the x-intercept is 2, 0. Write it in coordinate form. And we can even visualize where that is. 2, 0 should be on our graph, or somewhere near our sketch. Then our y-intercept, that's where it intercepts the y-axis, the vertical one. The x value here is going to be equal to 0. So when x equals 0, we're going to find out what y is. So plug in 0. To 3x minus 6 over x plus 2. So we get 3 times 0 minus 6 on top. That would be negative 6. 0 plus 2 on the bottom is 2. So that simplifies to negative 3. And our y-intercept is 0, negative 3. Put it on your graph, make sure it makes sense. 0, negative 3. Perfect. That is one of our points. Okay, go ahead and try one on your own. Pause the video and then restart when you're ready to watch the explanation. So first I'm going to identify A and C. A is 6, C is 2, and that means I can get my horizontal asymptote y equals A over C. Y equals 6 over 2, so y equals 3. And let's put it on the graph. Horizontal line going through 3. Then I'm finding my vertical asymptote, so I want to know when does the denominator equal 0, because we can't divide by 0. So 2x plus 8 equals 0. Solve, we get 2x equals negative 8. Divide by 2, we get x equals negative 4. Okay, then we know our domain and range follow from that. X cannot equal negative 4, y cannot equal 3. Our end behavior, as x is approaching positive infinity, we're going to be approaching 3, and we'll be approaching that from both directions. And then we go to our table. On our calculator, we get a few points lined up. So we have negative 4 in the middle is undefined. Then we have negative 3, negative 10.5, negative 2, negative 3.75, negative 1, negative 1.5, and 0, negative 3/8, negative 5, 16.5, negative 6, 9.75, negative 7, 7.5. And then I'll go find my x and y intercepts. So x-intercept, you set y equal to 0, which means only the numerator needs to be 0. And this is just because even if it's 0 over 3, it's still going to be 0. So no matter what we're dividing by, as long as the top is 0, the whole thing will be 0. So 6x minus 3 equals 0. Solve, we get 6x equals 3. X equals 1/2. So the point is 1/2, 0. And that looks like it is on our graph. Then y-intercept, we actually already have this in our table, but just for fun, for practice, we'll do x equals 0 and plug it in. So 6 times 0 minus 3 over 2 times 0 plus 8 equals negative 3 over 8. So that is 0, negative 3/8. And that's the whole problem. So next we're going to see one more method, or one more form. So this is about general rational functions, finding horizontal asymptotes. There's basically 3 rules, and we're going to see 3 examples that go with these. So if you see that the degree of the denominator is larger than the degree of the numerator, then we're going to have one horizontal asymptote. So an example of this could be, oops, let's write it up here, y equals 1 over x squared. What happens as we get closer and closer to infinity? So as x goes up, as it gets bigger and bigger, what happens to this fraction? Let's say it's a 1 over 1,000 squared. It's going to get really, really close to 0. So the end behavior tells you that you're gonna have one horizontal asymptote at the x-axis, or the line y equals 0. Next we have number 2. You'll see where the degrees of the numerator and denominator are equal, and that's kind of like we just saw with y equals a over c, except this time it has a and b, and it could be something like this. 3x squared plus 4 over 3x squared minus 2. Since they have the same degree, x squared on top and bottom, that means that the ratio of the coefficients in front of x squared are going to give us the end behavior. So it kind of mimics a constant function here. Because as we put in larger and larger numbers, like imagine we put in 1,000,000, then this 4 and negative 2 wouldn't really matter, but the 3 over 3 would, because that's the part that is with the highest degree. So this mimics a constant function of y equals 1, because it's 3 over 3. And then the last one that we're going to see is when the degree of the numerator is larger than the degree of the denominator. So an example of this could be x cubed over 1, right? So as x goes to infinity, it's just going to get larger and larger. There's no upper limit, so there's no horizontal asymptote. Okay, so now that we have all the basic rules, let's do some examples. First one we're going to see is when the degree of the denominator is larger than the numerator. So here we have degree of 0 on top, x to the 0 is 1, right? On the bottom we have degree of 2, so this is example 1, or type 1, and we're going to use our calculator to graph this one and see if there are any asymptotes. So are there any vertical asymptotes? When would the denominator equal 0? So x squared plus 2 would have to equal 0 for there to be a vertical asymptote. So we would subtract 2, we'd get x squared equals negative 2. And what's the square root of negative 2? Oh yeah, there isn't one. So there's no vertical asymptotes. For horizontal asymptotes, we're going to go by our rule. So since m is greater than n, or the degree on the bottom is greater than the degree on top, the x-axis, or the line y equals 0, is a horizontal asymptote. Okay, what is the domain and what is the range? Well, domain, we said there's no things that x can't be, so domain is all real numbers. Range is just from the asymptote. Let's actually look at our graph first for this one. So we're going to go to y equals, enter -2 divided by x squared plus 2. Second table. Just noticing the values that we have here. And it says to do a window from -3 to 3. So we have 0, -1 as one of our points. 1, 2, -2/3. Oops. 2, -1/3. And then we notice as we keep going, we'll never get to 0. Let's do a few negative points. So on -1, we have -2/3. -2, we have -1/3. And -3, smaller decimal. So we kind of get this very squished U shape. And we can also notice that we have a minimum here. Our minimum is at -1. So our range is going to be from -1 to 0. -1 because that's our minimum, 0 because that is a horizontal asymptote. Are there any x or y intercepts? So the question is, x-intercepts happen when y equals 0. So when does y equal 0? Never. Because of the asymptote. And then y-intercepts happen when x equals 0. So when does x equal 0? Right here, 0, -1. At that minimum. Okay, next one, number 2. This is when their degrees are equal. So notice we have x squared over x squared. Let's look at the coefficients. We have -1 over 1. So our horizontal asymptote is going to be -1 over 1, or just -1. So we'll draw that in. Y equals -1. And then we want to look for vertical asymptotes. So when does the denominator equal 0? And we can do this by factoring, we could do it by square roots, but I'm going to do it by factoring. I know this is difference of squares. X plus 2, x minus 2 will equal 0, so x could equal -2 or 2, and that would make the denominator 0. So that's a bad thing. That means that x equals -2 and x equals +2 are vertical asymptotes. They will cause us to divide by 0. Domain and range. Domain follows from our vertical asymptotes, so x can't equal -2, x can't equal 2, it can be anything else though. range, let's get a few points on our graph first. But we do know that it can't equal -1. And then x-intercepts and y-intercepts. So x-intercepts when y is equal to 0. And that's when the top is 0. -x squared equals 0. Well, that happens when x is 0. So 0, 0. And by finding our x-intercept, we actually just found our y-intercept too. If you were to plug in 0 for x, -0 squared over 0 squared minus 4 still gives us 0. So x and y-intercept are the same point. So far, we have a point at 0, 0. We know it's not going to reach -1. Let's get a few more points. So put -x squared into your calculator, and then divide by x squared minus 4. Go to second table. Let's get some points on our graph. We have -1, a third, -2. We have another error. -3 is -3 is -1.8. So down here, -4 is -1 1/3. Oh yeah, we do have an error because of our asymptote. That's right. We said x can't equal -2, x can't equal 2. So we've got curve in here, and then one 1/3, a little curve in here, and then we'll have one symmetrical on the other side. Okay, last example. This time, m is greater than n, so degree on top is greater than degree on bottom. That means that the part on top is going to matter more. So as this gets bigger too, but not as much. So the upper limit is infinity. So that means no horizontal asymptote. Are there any vertical asymptotes? Let's see if the denominator will ever equal 0. Yes, it will at x equals -2. So let's put that on our graph. And then, are there any others? Well, when we go to graph it, we're going to see this, but basically, if we divide these using long division or synthetic division, we would get another linear that would be, I think it's x minus 4. So we'll put a point at -4 and go up by 1/1. And this is what's called a slant asymptote. And you will not be asked to find these in Honors Algebra 2. It's just something that we want to be exposed to before Honors Pre-Calc if we do go that route. So that's a slant asymptote. We find it with long division, but not in this class. Okay, what is the domain and range? Well, we know that x cannot equal 2. Sorry, -2. And then, are there any x or y intercepts? X-intercepts set y equal to 0, and that means that the numerator equal to 0. Now this is a trinomial, we can factor it, x minus 1, x minus 1. Solve x minus 1 equal to 0, we get x equals 1. So the x-intercept is 1, 0. Right here. And then we can solve for our y-intercept by setting x equal to 0, or plugging in 0. 0 squared minus 2 times 0 plus 1 over 0 plus 2. Let's simplify that. 0 squared is 0, minus 2 times 0, 0, plus 1 is 1. 0 plus 2 is 2, so 1/2. 0, 1/2. Okay, so again, we can go to our calculator if we want to see more of these points, but the basic shape is going to look like this. Two symmetrical sort of parabola shapes, but that are on opposite sides, called a hyperbola. So there's some reference at the bottom if you want to put this all together, summarize what we did. Let me know if you have any questions. Don't forget to like and subscribe.